Hi everyone, welcome to the first video on the anti-differentiation topic. I'm going to be starting this off with exercise 11b, and we'll go back to do 11a later on during the topic. But to go over anti-differentiation, firstly, anti-differentiation is the opposite of differentiation. And so in differentiation, what we did was we subtracted 1 from the power, and we multiplied by the original power down the front here, and we're going to do the opposite of that. So instead of decreasing the power by 1, we're going to increase it by 1. And instead of multiplying by the original power, we're going to divide by the new power. So the antiderivative of ax to the n with respect to x is given by ax to the power of n plus 1, and that's divided by the new power, which was n plus 1. When we're writing an antiderivative, we should also make sure to write plus c on the end of it, because we can always have some constant term which would disappear if we were to differentiate. So something else that I should also point out is that this works for all values of n except for n equals minus 1. So I'll just perhaps make a note of that on the end here, where it's just saying for n is an element of real numbers excluding -1. And we're going to see how to deal with that situation of -1 there in one of the later videos as well. So to get us started, we need to anti-differentiate these ones here. First thing I'm going to do is I'm going to write it using correct notation. So the integral of 2x to the 4 with respect to x. Just so you know, integral is another word for antiderivative, and yeah, just another way of saying it. So when we do that, well, we raise the power by 1 and divide by the new power, and then also make sure to write plus c on the end. And the next one, first thing I'm going to do is I'm actually going to write it in a form where we can work with it. So that's going to become 5x to the -2, and that's now good to do. So the antiderivative of 5x to the -2 with respect to x is going to be 5x to the -1, increase that power by 1, then we need to divide it by -1, and I'm also going to write plus c on the end. Now I should probably take this one step further and make it look a bit nicer. So 5 divided by -1 is -5. The x to the -1, I'm going to write it in the denominator again, so it's in the same form as it was at the beginning, and just have that plus c on the end. And that is anti-differentiation. So find y in terms of x if dy dx equals 2 times the cube root of x. Again, what I'm going to do here is I'm going to write this in a form which we can handle. So that's 2x to the power of 1/3. And now to get back to y, all I need to do is anti-differentiate the derivative. So what I can say, sorry, I'll just be a moment. What I can say is that y is equal to the antiderivative of dy dx with respect to x, which is the antiderivative of 2x to the power of 1/3 with respect to x, and that comes out to be 2x to the power of 4/3, so I've added 1 on. I need to divide by 4/3 as well, and then have a plus c on the end. And I'll just finish this over here. So what I can then conclude is that y equals, now when we're dividing by a fraction, the very bottom number will just go up the top, and so that's going to give us 6x to the 4/3 over 4. The 6 and the 4 can cancel out, which is 3x to the 4/3 over 2. And I should be including my plus c on these as well. So there we have it. Now I haven't quite gone through all of these, but I will finish up the other example in the next video.